Welcome to CMG's webinar on leveraging the cloud for your dynamic work environment. My name is Jason Close and I'm the Canadian Sales Manager at CMG. And I'm very pleased to introduce today's presenters, Khoi Dong and Steve Snyder. Khoi has been with CMG for over 10 years, first joining CMG in 2007 as a co-op student. After graduating, he returned to CMG as a reservoir simulation engineer in 2009. And in 2012, Khoi transitioned into a new role as an account manager and has been looking after many of our Canadian clients ever since. He holds a BSc degree in biochemistry and engineering from the University of Calgary, and he is also a practicing professional engineer with APEGA and a member of the Society of Petroleum Engineers. Steve Snyder joins us from AWS, and he is a veteran of the US Navy and technology manufacturing industry. He's been with AWS for over 2 years and serves as a senior partner and manages the strategic relationships with independent software vendors in the oil and gas industry. So he's helping partners like CMG with technical enablement and go-to-market activities for our end customers. All right, so let's turn it over to Khoi and Steve.
Hi, everyone. Thank you for joining us, and welcome to our very last webinar of 2018. So today's webinar is called 0 to 60, Leveraging the Cloud for Your Dynamic Work Environment. Now, what does 0 to 60 mean? Does it mean you're seeing some slowing down on your runtime and you want to speed that up? Does it mean your requirement ranges anywhere from 0 to 60 different computers based on the day of the week? Or does it mean that your simulation workflows require you to run anywhere from 0 to 60 different models? Now, in reality, it's probably all of the above. So this talk will show you how cloud, whether on its own or in conjunction with your existing infrastructure, will provide you with a tool that's highly adaptable to the challenges that you see in your typical simulation workday. So to start, I'll discuss some simulation trends. And instead of me telling you what the trends are, we'll take a look at one of our very popular workflow, the unconventional simulation workflow. Now, this workflow is being used by many of our clients to characterize the reservoir, better understand the reservoir, and also how to better develop these unconventional assets. In a typical unconventional workflow, we see kind of 3 phases. So the first phase is the single well models, right? These allows you to study individual well characteristic, the actual fractures themselves, so the fracture length, the fracture width, the fracture conductivity, right? And you can also get to study and characterize the reservoir near the wellbore. So these models are fairly small, they're quick to run. You do have to run a large number of them just because of the different number of wells you're dealing with. Right? But because they're quick to run, the ideal hardware setup for this are typically multiple 4 8-core computer. You don't have to spend all the money on those big, massive computers for these runs. Okay, on to phase 2. Once you've done the single well models, you start looking at multiple wells or single pad models. Now, this part of the project allows you to study the interaction between the wells. Right? How does one well interact with the other? Where do I put my wells to get the most recovery? Are the fractures overlapping? Am my injected fluid goes from one fracture right into the next? These are typically larger, more complex, and of course they take longer to run. So for this case, you need a bit faster computer. So the ideal hardware setup for this would be the 8 or 16 core computer. So on to phase 3. Phase 3 now we're looking at multiple pads or full field models. Right? So these are extremely large, very complex, anywhere from 50, hundreds, or hundreds and hundreds of wells. And of course, they take a very long time to run. So for these models, to get them run in a reasonable amount of time, you start looking at those very big, very expensive computers that have maybe 36, 72, or 90 some odd cores on there. Okay? So note about this workflow is not sequential. So while you're doing phase 3, you might still be working on phase 2 and looking at the individual well, or you might be running some of the models, the mid-size models in between. Right? And this workflow is also not unique to just the unconventional side of things. Right? We see the exact same workflow in our SEGD, where you start up with a single well pair and you work your way up to a full field. And you see a very similar workflow in things like water flood or chemical flooding, where you start very simple models and work your way up to very complex models. So kind of in summary, the current simulation trends, we see varying fidelities of models within the same project, right? So you might run some small ones, some big ones, and some ones in between. There's a requirement to run different numbers of run based on which phase or which part of the project you're in. There's a requirement for on-demand availability, right? So certain times of the year, you might need extra additional hardware capacity to figure where the budget's going to go, whether to purchase a new asset, whether to stop development on a certain asset. Those requirements are always there. And finally, probably one of the very most important thing that everyone looks at now is cost efficiency, right? How do I get the most for every dollar I spent? So this is kind of what we need to do. This is part of our workspace. What are the tools that we have? The computer, how does that, what do we have to use to meet these requirements? So with a few exceptions out there, most of our clients kind of fall into one of these two categories. Right? They either have the standalone workstations, so these are the individual computers, that individual engineer desk to be used by that engineer. The downside to this is that the hardware or the resource is not shared. Right? If the engineer is not using it, it's not accessible to someone else that might need it. Option 2 gives you a little bit more flexibility. Option 2 is your centralized compute nodes or clusters. These are physical data centers that holds, hundreds, maybe thousands of cores that can be accessed by the users from any of the offices. The upside to this is the resources are shared. So if someone's not using one, it's available to another person. The downside of this is that it takes a long time to set these up, and also it's expensive to maintain. So this is our tool. These are the tools that we have. How does that kind of match up to what we see as our simulation trends currently? Okay, so we look at varying fidelities of models. We know that the existing hardware, whether it's the standalone nodes or the data center, the type and the capacity are static. So the type of computers you have and the numbers you have available are fixed. Now, if that ratio doesn't change, yet your requirement changes throughout the life of the project, you can see that would lead to some inefficient use of the hardware. Right? What about varying numbers of simulation run required? Right? We know that these data centers take a long time, or even individual computers take a long time to get upgraded, right? Between asking for approval, getting the approval, purchasing the hardware, install it, and setting it up. That's a 6 months to a year kind of time. And you have that kind of time to wait on some of these answers. What about on-demand availability? What we see with our client is that there are some limited capacity for on-demand and for user spike. A lot of companies have to kind of balance the line between paying for excess capacity, but also paying for idle hardware when not being used. Right? So what we typically see is around a 5 to 10% excess capacity. So that is there, that's available. But if you need double the number of computers or triple the number of computers, that typically is not feasible with the way things are set up right now. Right? What about cost efficiency? Right? We know that hardware maintenance are expensive. And on top of that, the hardware becomes obsolete very quickly. So all this money that you're paying to maintain the hardware, do you have access to the latest and greatest? Most likely not. So in general, what we see is that our workspace, our work requirement is changing, it's dynamic, whereas our existing hardware is fixed, it's static, and it lacks the agility to adapt within a reasonable amount of time to what we need. So what is the solution to that? So as alluded to earlier, we here at CMG, and along with our partner AWS, believe that the cloud is the next tool that will revolutionize the way you use a computer. The cloud offers flexibility, agility, and allows you to adapt to a very challenging and changing work environment. So what is the cloud? At its very simplest form, the cloud is a set of computers that are connected and that allow the users to log on and use at any time and anywhere. So at CMG, we've been focused on offering cloud or some sort of cloud for quite a few years now, beginning with our own hardware and our own data center that we offer for the past 8 or 9 years. In the last couple of years, we partnered up with a few other cloud providers in the industry, namely MS Azure and Amazon AWS. Okay, and we partner up with these providers to leverage their vast network of data centers. Right? These guys have the data centers located throughout the world, right? And with that partnership, we now can offer almost infinite capacity and configurations. So not only you have access to unlimited number of cores, but you can configure them to any way you want, whether it's one small computers or 10 really big computers is available there for you. right? They offer secure and instantaneous access at any time and anywhere, right? So whether you're at a hotel, at home, at a cottage, you can access these services and use them as you need it. We also work closely with our partners here to provide you a very simple and easy to use interface. And you will see this in our demo in a little bit. All you need to worry about is which data set I'm gonna submit and where do I save the data set. They're the only thing you have to worry about. And of course, all these clouds work seamlessly with our integration to CMOS AI. Right? So allow CMOS to access the clouds, submit the jobs, and allow you to provide you with an answer in a reasonable amount of time. So this is a very kind of top view of where the data centers are located. The white cloud is our data center located here, right here in Calgary. All the colored clouds are data centers belonging to either Azure or Amazon AWS. The way they are distributed, kind of based on a couple of reasons. First, it's give you quick and easy access anywhere in the world, so you're never too far from a physical data center. Right? Secondly, they offer country requirements. Certain countries you can't pass data outside the country borders. So the way these are set up, they allow you to use the cloud without having to violate any of those rules. And secondly, and Steve will talk more about this in his slide, is these locations of these data centers also allow for failover and backup. So if one data center falls down, or sorry, goes offline for some reason, another one will be ready to pick up its place in a seamless transition. Security of your data. Security of data is one of the biggest things on our clients' mind when we first brought up about cloud. And we here at CMG and also with our partners take them very seriously. For the login, there are two-factor authentication. So you require not only your password and your name, but if you like, there's also a third option, a third credential you need to add, which is a dynamically changed key, an MFA key or Google Authenticator that you need to log in to see your data or to submit your jobs. Right on the actual transfer itself, it's highly encrypted. Okay, I believe Azure uses 256-bit encryption. AWS uses the S3 encryption to store and transfer your data. So I'll take a bit of a break on my end, and I'll transfer over to Steve to discuss what AWS has to offer and what makes them one of the industry leaders in that field.
Thank you, Coy. Good morning, everybody, or good afternoon. I'd like to give you all an overview of Amazon Web Services, or AWS, and how cloud computing is impacting our world, and specifically how we enable innovation in oil and gas. Now, all of you, or many of you, if not all of you, are using AWS in some form or fashion, whether it's with Amazon.com, Netflix, Lyft, Airbnb, buying and selling shares. Cloud computing and AWS is very pervasive in our world today, but specifically, we're going to talk about what AWS is doing for oil and gas in today's world. And in order to just show that, let's just take a quick look at a graphic here. On Easter morning in 1900, this is a shot of Fifth Avenue in New York City, and we'd like to ask you to try and find the car. And there it is right there with that circle. Now, just a few years later, this is Fifth Avenue, and we'd like to ask you to spot the horse. So in just a short period of time, there was 4,000 registered cars and very, very difficult to find the car on Fifth Avenue. And then just a few years later, now you can't find the horse. And today there's 270 million cars in the US approximately. So we think that that's the type of transformation that's taking place in oil and gas enabled by cloud computing, but we don't think it's going to take quite that long. And that's illustrated by a couple of pieces of data here in the next slide. If you look at all these projections, 2005's prediction versus actual outcomes, this is just a data point and a snapshot, from the US, but we see this from all over the world. And if you look at this, it's pretty clear that there's a pattern in this technology and that volatility and change are here and will continue to be here. So what that means is that every company in the world is going to have to keep transforming to keep their customer experience and their business innovating continually in order to remain competitive. And while having lower cost infrastructure is an enablement for this transformation, it's really not the main driver. The main driver is agility and innovation, and the cloud enables these in a very significant way. In the old world, if you asked a developer or an engineering team how long it might take them to get a server to try and experiment, you would get an answer like something like 10 to 18 weeks. Today, you can spin up thousands of servers literally in minutes. So this gives you very robust, full-feature technology that lets you go from idea to launch in record time. Now, specifically, I wanted to talk a little bit about AWS or Amazon Web Services. Most of you are familiar with Amazon.com, and here's some of the other innovations from Amazon as a company up through the Amazon Go store. But let's talk specifically about Amazon Web Services, which was launched in 2006 after a decade of building and running the highly scalable web application Amazon.com. And since our creation in 2006, we've grown to serve millions of active customers every month across 190 customers. And we've developed into a $10 billion run rate business faster than any other technology company in history. And we've gotten here because we keep customer obsession and constant innovation behind everything that we do. Cloud has become the new normal, either to deploy new applications or to transform on-premise applications and to gain new efficiencies. Now, what would he say by cloud computing? Coy touched on this just a little bit. It refers to the on-demand delivery of IT resources via the internet with pay-as-you-go pricing. So instead of buying, owning, maintaining your own data centers and services, enterprises can just acquire technology such as compute, storage, databases, etc., literally over the internet and literally on an as-needed basis. It's very analogous. We like to draw a comparison to how consumers get electricity delivered to their house with just a flip of a switch. You flip the switch, the lights turn on, you turn the lights off, and that's all you pay for. Capacity can grow or shrink instantly, and businesses only pay for what they use. If we just dive a little deeper into AWS or Amazon Web Services by the numbers, our most recent quarterly announcement showed that we had a $6.68 billion quarter, which is a 46% year-over-year growth rate. Operating income of $2 billion, and that accounted for about 56% of Amazon's total operating earnings. Just some other supporting numbers that may be of interest to you all. We've reduced prices 67 times since our inception in 2006. We launched over 1,430 new services and features in fiscal year 2017. I'll get into that in a little bit more here. And with companies like CMG, we added over 10,000 partners in 2017 as well. Now, as Coy mentioned, AWS spans the globe, and this makes it easy to meet regional compliance and data residency regulations. AWS has the concept of a region. Now, a region is a physical location around the world where we cluster multiple data centers. They're geographically separated into what we call availability zones, or AZ. Each AZ is a data center or a collection of data centers engineered and designed to provide full independence and fault tolerance from other AZs in the same regions. All regions have at least 2 availability zones. Now, other cloud providers will call a single data center a region, but as you can see, we believe that our approach gives you a fundamental advantage and fundamental durability and reliability advantages, and that's why Gartner calls our approach the best way to run enterprise apps that require high availability. The AWS Cloud operates 57 availability zones, 19 geographic regions, and we've announced plans for 15 more availability zones and 5 more regions in Milan, Bahrain, Cape Town, Hong Kong, and Sweden. All that's depicted on the chart here. We also have 150 points of presence in 63 cities across 29 countries. This chart shows the pace of innovations and the number of significant features and announcements we've made throughout the years. And as I mentioned earlier, 1,430 just in 2017 alone. And we fully expect, especially in the wake of our users conference reInvent, which happened earlier this month, that this pace of growth is going to continue. Customers benefit from this continual evolution, innovation, and iteration because they get the newest and latest features, and there's no need to update, deploy, or migrate. Specifically, recently, and we'll talk about this a little bit later, we announced C5N, the instance that CMG utilizes with 100 gigabit of connectivity, and AWS Data Sync for replicating on-prem data to the cloud. We get all of these requests, and we drive our roadmap with input from our customers and partners. In fact, 95+% of our roadmap, we say, comes directly from customer input. And we hear from some customers that all of our services and launches are great, but can be overwhelming. So it's our pleasure to work with CMG to identify the technologies that matter most to our customers' workflows. Coy touched upon this briefly as well, but security is always our top priority. And if you look at the AWS cloud, you'll see the same security isolations that are employed that you would find in a traditional data center. This includes physical data center security, separation of the network, isolation of the server hardware, and isolation of storage. We have a shared responsibility model with our customer. AWS manages and controls the components of the host operating system and the virtualization layer down to the physical security of the facilities. And our customers are responsible for developing secure applications. AWS partners offer hundreds of tools and features to help our customers meet security objectives, and that ranges from network security, configuration management, access control, and data encryption. We're very vigilant about our customers' privacy and have implemented sophisticated technical and physical measures to prevent unauthorized access. When we look at oil and gas, Amazon Web Services can accelerate digital transformation to help you find oil faster, recover more oil, reduce the cost per barrel, and reduce risk and ensure compliance. Some specific use cases that we have, well, let's just quickly summarize some of the use cases that we have in the next slide here. Everything subsurface, seismic, reservoir simulation, obviously with CMG, which we'll talk about, up to oil field operations on up through retail. So a full span of use cases. Specific to HPC and how that enables our partner CMG, technical workloads like ResSim continue to push the bounds of exploration. And as part of our commitment to address the challenges of these computationally intense workloads, AWS continues to innovate new services for HPC on behalf of our customers. At the center of running all these HPC workloads with CMG on AWS is Amazon EC2, or the Elastic Cloud Compute. With more instances optimized for different workloads than any other cloud provider, we're excited to work with CMG to evaluate our C5N, which I mentioned earlier, compute instance, which supports up to 100 gigabit of connectivity, and to AWS with intra-instance to AWS storage. Networking is also a vital component in this space, and in addition to the reduced jitter and high bandwidth already available on AWS, we recently announced the Enhanced Fabric Adapter, or EFA, for select AWS EC2 instances. EFA enables even better latency for workloads that scale out for workflows like reservoir simulation. We're pleased to be partnering with CMG. We're currently leveraging AWS Batch, EC2 HPC optimized instances, and networking and storage best practices to delight our joint customers via the CMG AWS Cloud offering. Diving even deeper, the AWS Cloud is built from the bottom up to satisfy the most demanding and secure applications in the world. These start with best-of-breed computational elements, which you can see on the left. You'll see the custom Intel Scalable Skylake processor, which powers our C5 instance family. Next, the Nitro Interconnect, which was developed by Annapurna Labs, an Amazon company. And then finally, in the bottom left, the NVIDIA Tesla graphics processing unit that powers AWS graphics optimized for the G3 instance family. CMG has been able to apply these optimized services to architectures tailored specifically to the ResSim application to achieve time to results in the fastest and most secure way. The C5 instances running on AWS Batch for CMG have additional power per vCPU and provide a 25% price performance improvement over the prior generation of C4 instances. The Nitro Interconnect leverages AWS compute optimized instances, and CMG is able to offload the entire EC2 software stack. That means storage, networking, monitoring, security, hypervisor management, are all offloaded to the Elastic Network Adapter, freeing up more cycles to accelerate time to results on all at no additional cost. And finally, at the end of the day, when it comes to virtualization, which is only a tool for the engineer, Amazon AppStream 2.0 running on EC2 GE instances gives you access to Windows desktop applications through a web browser. With initial positive feedback from CMG customers, we're excited to work with CMG to make this capability available within the CMG cloud. So as I mentioned, we partner with CMG, and they're part of the AWS Partner Network, or AWN. The APN includes tens of thousands of consulting partners and technology, or ISV partners, and we added over 10,000 partners in 2017 alone. The majority of Fortune 500 companies and over 90% of the Fortune 100 companies utilize AWS APM partner services and solutions. The APM partners provide you value-based software and services across virtually every use case and can accelerate your engagement with AWS, helping you go from idea to solution even more quickly. CMG specifically has earned our designation as an advanced technology partner of AWS, meaning that they have even greater access to higher levels of programs and benefits that enable the AWS CMG team to provide even greater support to our end customers. The last couple slides I'd like to leave you with are just a couple of quick examples of how AWS has driven customer success in oil and gas. This slide depicts some valuable work that we completed with Hess, and it's summarized with the quote by Jeff Davis at the bottom. The performance of jobs using both CPUs and GPUs is comparable between the cloud and on-premise. And then lastly, with Woodside, it gives a quick overview of a project and shows the way that AWS likes to engage with our customers. We like to leverage all the capability that the cloud can offer and encourage our customers to think big, prototype small, and scale fast. And working with CMG, we hope to be able to do that with you and innovate in such a manner. And thank you again for your time. With that, I'll kick it back over to Coy.
So thank you, Steve, for that. So quickly look back that we know what the clouds are, what are its capabilities. How does the cloud match up to our current trends in the simulation world? So looking at varying fidelities of models, so different type of models you need to run the same project. Cloud solves this by giving you instantly scalable and flexible hardware options. Right? So whether you need a small computer, a few small computers, a few large computers, or a few hundred computers, it's there for you at your fingertips at any time you need to. All right, what about different number of runs that you need to do? Once again, almost infinite capacity, right? So by leveraging our own cloud, Azure, and Amazon AWS, you now have access to a large network of data center, and you can have access to as many cores you need, and you can configure these cores or these computers to any way that you want. On-demand availability, of course, the instantaneous access, the 24/7 access allow you to access these computers at any time, anywhere to meet your project deadlines. So whether you're in your office, whether you're at the airport waiting for a flight, or at a summer cottage, you have access to these computers at any time you need to. Right? And cost efficiency, cloud offers you pay as you go, as Steve mentioned, only pay for the hardware and the software that you need. And also, almost as importantly, you have access to the latest in hardware and software. For the same amount of money you're paying, you always have the best, the fastest available hardware. So with cloud, we now can remove that bottleneck that we've experienced with existing hardware configurations. So cloud, once again, on its own or in conjunction with your existing hardware, will allow you to arrive at your answers much quicker. Right now, you can have a decision, you can have the information you need to make that decision, whether to drill a new wells, whether to wait till next year, whether to purchase a new asset. All those decisions can be now made in a much quicker time. So now I'd like to switch up the presentation, the webinar a little bit, and we'll show you some demos on first how we can submit a data set. Okay, so as Steve mentioned, we work closely with Amazon AWS as one of their technology preferred partner, advanced technology partners, sorry. And from that close association, we were to develop an easy and effective way to submit your data set. So what we have for AWS, and we have exactly a very similar app for Azure, and it works the exact same way. It looks very similar. But in the interest of time, I'll just demo our AWS app. Okay, when you install the 2018 software, this app will be available for you. So if you double click on this app, it opens up a window. Okay, so it's gonna connect to an AWS application, and it will ask me to log in, right? So right now, I do not use the two-step authentication, and you can set up that in your account setup. And if you do have that, there'll be a third window to ask you for this dynamically key. So I will log in. So when you log in, anyone that uses our software using Launcher or CMOS is a very similar layout. You have kind of a list of jobs. This is a job that I ran yesterday. Okay, now to submit a job, it's very simple. On the upper left here, you can click on this menu and you go submit new data set. So here you can select the data set, where you want to submit it, or where that data set is located. Okay, so I have a waterflood data set here that I will open. Okay. You can pick the data center. Right now we have Montreal, Oregon, and Mumbai set up for myself, for my specific account. Any user can request any data set anywhere in the world, and we can set it up for you. You can pick the type of computer that you want to run it on. The half computer runs fast, the full run faster, and the mega run the fastest. So based on the size and the complexity of your models, you can pick one of these nodes. For this one, I'll use a half. It's not that complicated of a run. Simulation, of course, IMAX, GEM, or stars. This one, I believe, is an IMAX. Okay, and for the version, we keep a couple of versions on here. One note on the version is that you always have access to the latest version on the cloud. So without having to wait for IT to vet or to test it out, if on the cloud, you always have the latest version, which allows you to access latest features, things like auto tune or commute solver that helps you run your model a lot faster. Okay, so once you have that all done, these are the same kind of setups or checkbox that you have in a typical run if you need to use them. I also have an option to notify by email. If it's a long job that you don't want to sit around and wait for, you can click it. It'll send you an email once the job is finished. So when I click submit, what it does is first it'll zip up the file and it'll send the file onto the Amazon AWS server. On that server, there's a slight wait, probably about a 30-40 second wait while it kind of create a container, it transport it to their S3 storage, it locates a node and it'll submit it to the run. Okay. So while that's waiting, I'll show you another way that you can submit your run. If you have the AWS app open, you can go to the folder with your data set and you can just drag and drop. So I can drag, so I'll take this data set. Okay. And I drop it on here and it'll ask if I want to submit that run. Okay. And the exact same window popped up. In this case, I'm going to use GEM. This is a GEM data set. Okay. And I'll go OK. So you can see our first submission is currently running, the waterflood one here. Okay, and while it's running, I can right click on it and I can see the out file or the log file, exact same kind of workflow you would use as a local machine. The log file shows you kind of an overview on your run, just to make sure your run is looking good. It's not doing anything weird. Material balance look okay. Your time step cut looks okay. So exactly what you would use if it's on your desktop. So on a finish run, we have a finish run here. I'll click on that. You can expand it. Okay. And you can see for the run that has not complete, there's no available for download, but the run that finished, this waterflood one here, you can now download by clicking on this arrow here. Okay, so once you click on the download arrow, it'll show you files that you can download. It will automatically zip up some of the bigger files, the things like your log file, your text that can save you some room. Okay. And then you can click on your download. So we can download the SR3, which is your results file. Okay. Now, if you click download, it'll download, right? And then it will, if you notice, it's about 22, 23 megabytes for that one. It's fairly quick, even a file that size, and it automatically opens up the folder where your files are being saved. In my slide, I mentioned that CMOS is also cloud capable. Right? So I open up my CMOS here. Right? In the submit run option, okay, you can see that now, once I've logged in, Amazon and Azure, as well as the local machine or any data center that you have, will be available for you to submit your run from CMOS. So multiple different ways to submit runs, very simple, very effective on how to submit your runs. So in conclusions, CMG offer you multiple different solutions to the cloud, and in partnership with our partners like AWS, will allow you to improve your project delivery with instantly scalable and flexible options based on what you need. You have access to the latest CMG software releases and also the industry's best hardware. And speaking of latest software releases, with 2018, we are now MPI capable, so we are able to take advantage of distributed memory and spread out or parallelize our runs over hundreds and thousands of cores. That's another advantage that a typical standalone data center might not have. For the cloud, it provides secure access to anywhere, from anywhere in the world at any time. You can submit your runs, and these capabilities are at your fingertips at any place, at any instance that you need. Right? And of course, with this, you can improve usage efficiency and costs by using pay-per-use. You no longer have to pay for idle computer or computers not being used at all times. Okay, and ultimately, all of this works seamlessly within CMOS AI, allow you to take advantage and leverage those multiple cores to get data back that CMOS can analyze and help you arrive at your decisions. So that's the end of our talk. Steve and I are still here, and we're more than happy to take any questions that you might have.
Thanks, Goy. And Steve, we really appreciate the presentation today. So we're now ready to answer your questions. If you have any questions and have not already submitted them, you can do so now using the chat window on your screen, and we'll do our best to answer as many questions as we can in the time frame we have left. Ben here has asked us a couple of questions. The first question he asked was, what is the difference between using the CMG AWS cloud, running the simulation on a virtual machine with CMG installed? And I hope the demo you showed from Koi is you're not going to see very much difference in how you go about launching that. So CMG and AWS have worked together to try and create as seamless as possible solution for our customers to do so. But what you should see is hopefully better performance and better allocation of resources. Ben also asks, how does job simulation work with include files? And in that launching window that Koi showed earlier, if you pick a data set, what it does is it scans through that data set and look to see if there's any include files. And if there's include files in the same folder, it automatically picks them up. If they're not there, it'll give you sort of a warning that the include files are not there. So there's a little bit of assistance in the interface to make sure that your include files are picked up. I've got a couple questions here that ask about price structure. So what I'd like to recommend is that you contact your direct salesperson, or you can reach out to me directly and we can discuss that as well. We do have on-demand pricing available to help our customers who have scaling needs and requirement to do larger projects, for instance, like CMOS projects, or to meet peak demand. So I recommend that you speak to your CMG folks about that. I've got a question here from Ali, and Ali asks, what is the biggest simulation you can run in the cloud? Well, that's a tough one to answer because I don't really think we know what that is yet today. But what I can tell you is that we've run thermal data sets with over 100 million grid blocks. We've run compositional ultra deep water models with over 100 million grid blocks and 15 plus components. So pretty large models, and we're able to do that through distributed computing models. And that kind of brings me to my next question from Sarah, who asks, what about distributed computing? So as many of you may or may not be aware, CMG, besides doing shared memory computing, which allows you to do parallel on single nodes in the cloud, we also offer distributed memory computing, which allows you to run your jobs across multiple different nodes or computers in the cloud to help accelerate your problems. So for those very large problems, that's exactly what we're doing. And in fact, CMG is doing all of our distributed memory development through the cloud because it just makes more sense for us as the different size clusters we need to run different types of models. It just makes more sense to do that in a scalable situation. I've got a question here from Chris, and he says, the challenge that I have, as I'm sure others do, is CMG is one of many applications in an oil and gas company's toolbox, and the challenge is getting the inputs and outputs out of a cloud solution like this. So what we've done is we've worked pretty hard very recently to look at how you can visualize and decide what data you want to bring back beforehand. So you saw Coy just showed you some of our latest work using AppStream to help us to do some of that stuff. And that's to help our customers decide exactly what they want to bring down and up. We also are working with AWS on faster ways of upload and download, which should help with performance of that as well. And beyond that, AWS has many different types of storage. So they have the ability to not only use S3 storage, which is a very secure piece of storage that we're using to do the simulation, but they have situations where they can have multiple types of storage to do that as well. And I've got Walker here and Steve here that can maybe answer a little bit more about what sort of storage is available and how much data can I store in the cloud.
Well, much like with compute, the storage options are virtually unlimited. We have use cases that go all the way to exabyte scale for block, file, and object storage use cases. Additionally, we have broader and additional options for storage archive, including Snowball, Snowmobile, all of which can move data to AWS at grand scales. And then lastly, there's the cold archive option of Glacier. So much like Jason said, your individual use case, we're happy to work with you through CMG to figure out the option that'll work best for you. But the options and the amount are virtually unlimited.
All right, thanks, Steve. So I've got a question here from George, and he goes, how long did it take and how much CMG resources were required to ship these CMG applications to AWS? And to be honest, AWS has provided us with a lot of tools to help with the migration, but we're not done. So we're continually working with AWS to figure out the best ways to do so. As you can see with what Coy showed us, we have several different types of nodes available, and we're constantly testing new hardware architectures in that environment that will help our customers to run faster. So with time, you'll just see your runs going faster, and it's because we found better ways to run and different systems to run on within the AWS environment as they add new proprietary hardware. Okay, and then I've got a question from Gian, and it says, does the CMOS multiplier work with cloud? And the answer to that is yes. Really, one of the main use cases we see initially with an on-demand cloud solution like the one we're providing is the opportunity to run CMOS AI, to run assisted history matching or sensitivity analysis in the cloud. For instance, with sensitivity analysis, we know all the runs we want to do ahead of time, and in a static hardware environment, we're kind of stuck with how many simulation or how many computers we have. The great thing about this is that I can run all those jobs at the same time and get to a solution faster, all for basically the same price as it would be to run them sequentially. So there's a great advantage to reducing time to decision, and it hopefully will enable our customers to go ahead and run the cases that they want to run instead of being forced to run the lower number of cases that they have to do to meet the time to decision. Well, we are just about running out of time here, so we'll just close out here. I'd like to thank you for your questions, and that'll wrap up today's session. If your question wasn't answered during the Q&A session, we'll follow up with you with the next few days to make sure we can do our best to answer those questions. Again, if you had questions about cost, go ahead and reach out to your CMG salesperson to talk about that. I've hoped you've gained a better understanding of how using cloud computing can enhance the value of CMG software. And we'll post today's recorded presentation to our website within 24 hours so you can show that to your peers within your organization, which I recommend you to do so. CMG offers a multitude of training courses for all skill levels, and we also offer company-specific courses on a variety of other subjects all around the world. So for more information on our training courses offerings, please visit our website at www.cmgl.ca, or you can contact training directly at training@cmgl.cmg. Again, if you have any questions related to the material presented today, we would like to know more about or would like to know more about our product offerings, please email us at cmgl.ca. And again, thank you all for joining us today for the webinar, and we look forward to connecting with you again.